Right, then our second engineering drawing that we're going to create using CAD is a third angle orthographic projection, and I'm going to show you how we do that now. So we're going to again go to our insert new tab, and we're going to create a drawing. We're going to use exactly the same template, the ANSI A millimeters. Click OK. Small lag. Be patient. Okay, now the idea of the third angle orthographic drawing is a very technical drawing, and there are rules that we must follow when we create our third angle orthographic drawings. The reason we have these rules in place is because the idea of this drawing is that it would be given to an expert who could then make the specific component that we have created the drawing for. So it might go to a factory, and they would then use the information you're drawing to make the part that you've created. Now that factory could be hundreds of miles away, thousands of miles away, different part of the world. So it's important we get into the habit, and we are consistent with how we produce these third angle orthographic drawings. So I'm going to start with the side plates. I'm going to choose my side plate. So I've clicked on my side plate. Now, the way we lay it out is we want our front view in the bottom left, we want our right side view to the right, and we want our top view up to the top. Now, because I sketched these in the right side of plane, I'm going to manipulate the drawing a little bit so that we've got our front view where I'm hovering the mouse at the moment. So I'm going to go up here and I'm going to choose a right side. And again, that's far too big, so I'm going to change the scale. I'm not sure why that isn't going down. That should. Put 1. That's 3 to 1. I want 1 to 3. Yeah, 1 to 2. That should be fine. So I've chosen the scale 1 to 2. So for every 1 millimeter or 1 centimeter in the drawing, it's worth 2 or millimeters or 2 centimeters in real life. So I'm going to choose my front view here. Clicked. So if I now move my mouse off, it's now going to give me a side view, and you'll notice it's lining it up, and that's one of the rules with a third angle orthographic drawing. We want our side view and our top view lined up with each other. So I'm going to click. There's my side view. Okay, I'm going to go back to my front view. I'm going to click on my left mouse button. I'm going to move it up, and it's going to create a top view. Those are my 3 views: front, top, and right side. Now, we need to add a bit more information. There's 2 things I want you to do. I want you to add in what we call hidden details. So if I'm looking at this front view, I can see, and I'm going to zoom in on my roller ball on the mouse. I can see those 2 through holes at the front there. Now if I project up to my top view, at the moment I can't really see where those holes are, and I wouldn't be able to see those in real life because there's material at the top and the hole sits halfway down from top to bottom, which we know that because we can see that on our front view. But it's important we understand that there is something there. There's a hidden detail. We can't see it from the top view, but it's there. So we're going to right click on the view, and we're going to put show hide, show hidden lines. Now you can see that these hidden detail lines, and they're dashed, they line up with the outside of my circles. I'm going to do exactly the same on my right view. I'm going to right click, show hide, show hidden detail lines, and you'll see that those hidden detail lines, and I'm going to roll in so you can see them, dashed lines, and they line up exactly with the top of the circle, of the hole, and the bottom of the hole. That's really important. So now we've got our drawing laid out correctly, we now need to add the dimensions that are going to allow a factory or someone else with the technical knowledge to be able to make this product. So we use our dimensions tool. And we need to think about what are the key bits of information, and I would, as a rule of thumb, as a general rule, I would probably say don't add any more than 5 or 6 dimensions per view. So it's important that we know what the diameter of that circle is. So I've clicked on the circle and I've moved my mouse away, and I must make sure that my dimensions are off of the drawing, off of the sketch, because otherwise it can be confusing for someone looking at a drawing, not be able to talk to you, not be able to ask you information about it. They have to be able to read what's on there and understand it. Otherwise, when they come to make it, there's a good chance they may not be making it in the right way. So we've told them that that through hole has to have a diameter of 8 millimeters. The next thing I'm going to tell them is what bend radius we want. So what curvature do we want on the end of our Bike multi-tool on the side plate. So I've clicked on that bend and it's telling me it's R. R stands for radius. It's a 15mm bend radius. So I want you to do that. The next thing I'm going to tell it is I'm going to tell it the actual overall distance. But I might do that on my top view. So I've got 2 key dimensions on my front view. So I'm actually going to go to my top view now. So I'm moving up to the top view. I'm going to click on that left. I'm going to zoom right in as far as I can, so it's really obvious and easy for you to see. I'm clicking on that left line. I've clicked once. And I'm going to click over on the line here. And I'm going to take my dimension off of my drawing. When I put the dimensions in, they must fit in the middle of the 2 thin full arrowheads. So click. So there's my dimension line, and it's telling me it comes from the edge, thin full arrowhead. My dimension sits in the middle, thin full arrowhead, dimension line. What we call those like a projection line. We're projecting it up. There we go. So let's go and look at our right side view. What information could we add here? Well, I've told you what size diameter the hole needs to be drilled. I've told the factory what bend radius to add to the outside of the side plate. I've told them what the length of the side plate needs to be. What I need to tell them is the thickness of the material. I'm going to use that. I'm going to do it here. Now, very small space, too crowded, doesn't look very nice. So that's the way we add it on small, when we've got small dimensions to add. That's how we do it. And again, we're trying to be consistent with the way we present our information. I'm trying to keep it off the drawing. It's not. It is close enough to the drawing so it's obvious which part it relates to. There's one final dimension that I want to add. I might add it to my. There's a couple yeah. So I want to tell the factory. I've told them what diameter to drill the hole, but they don't know what distance to drill it from let's say the top down. So I can either tell them on this drawing. So I'm going to tell them that the centre of that hole to the bottom needs to be 15mm. And this is a great example where CAD will help you get things right. It introduces, as I bring my dimension over, as I get towards that 3, it produces a nice little perforate, like a dotted purple line. It's saying, sir, you've got those two lined up. That's a good thing, because it helps keep a nice clear view of your third angle orthographic drawing. So I'm going to click there, and I also want to tell them the distance between the two holes. So I'm going to go to my top view for that, and I'm going to click on the center of that hole and the center of the hole on the right, and again there's my purple dotted line helping me line things up correctly. And I'm going to leave that. I think that's pretty much the key information that we need. I might add on the height, so there we go. Again, it's not a choice, this is something we have to do. We have to make sure that dimension is in the middle between those two arrows. It's neat, it's clear to read. So that's that done. We now need to tell, by clicking dimension, we now need to put some information down here in this box. This box is called a title box. We don't need to worry about a surface finish. We haven't drawn it yeah, we've got a scale down here, 1 to 2, it's put in there for third angle orthographic projection. That's the third angle orthographic projection symbol. It gives your name, it puts the date in. Don't worry about who's checked. Again, that will be in the factory when it's being made. They would have little quality control steps in place to make sure that things are checked once they're being made, to make sure they are correct. And maybe a manager or a boss might then approve it. What we are going to tell them is what material. So we're going to make this from plastic. And our title is going to be the sidebar. The drawing number. How many drawings have we got? We'll probably have about 12. Maybe slightly fewer, but we'll put 1 of 10. And green ticket. It's already put the scale on there for us. Don't worry about the weight. It's not essential for this particular drawing. So that's how we've now created a very simple, very straightforward and easy to understand drawing, third angle orthographic drawing, technical drawing of our side plate. That could now be sent off to a factory. They could take that information and they could have a go at making the part for us. I just want to check, have we got dimensions on here? Usually it'll default to millimeters, unless, there you go, unless otherwise specified, dimensions are in millimeters. That's common on engineering drawings. We like to use millimeters because we can be really precise. So unless the drawing specifies that it's not in millimeters, just assume that dimensions on an orthographic drawing are in millimeters. Right, I want you to have a go at creating orthographic drawings for all of your component parts, making sure that we are sticking to these rules of laying things out in a lovely, logical, clear manner. Our dimensions are sat in between the arrows on our dimension lines, and we have our front view on the left, we have our right side view on the right, and we have our top view, and all three are lined up perfectly with each other. Give that a go.